Hello, my name is Will, and welcome to this quick guide on how to get started with PLC programming for free. We will be starting off with a simple setup that will give you some exposure to ladder logic diagrams, OPC servers and clients, as well as physically applying your program to a physics based factory simulator. For this lesson, we will be installing all of our software you'll need to begin programming and simulating your logic. We're going to be using two programs. CodeSys will be the program we use for designing our ladder logic as well as setting up our OPC server, and FactoryIO, which has a built-in OPC client functionality as well as fully physics simulated environment. And it's even got some machines that you can use to build your own system and simulate your PLC code. Okay, so first things first, we're gonna get started with downloading our programs. FactoryIO is gonna be the first one we download. Just go ahead and type FactoryIO into Google, and it is the first result. We're gonna try for free. Set up your account, and then you can start your download. I've already got it downloaded, but there aren't any fancy tricks. Just go ahead and get that downloaded. Run the installer, and then we'll move on to CodeSys. CodeSys is the next program that we're going to download. If you are in North America, like myself, you are going to need to type CodeSys 3.5 North America. There is an international and there is a North America store. And if you try and go through the international store from North America, it just kind of blocks your account. So you need to make an account in the North America store and download your software from here. So we're going to click on this. And just depending on whatever your system is, download 32-bit or 64-bit. I have a 64-bit system, so I've downloaded 64-bit. It does take a while to install CodeSys, so you might want to pause the video and just come back when it's unpacked everything and you've got it all installed. And we'll get started from FactoryIO. Okay, upon initially starting FactoryIO, we have some documentation here. You can get some really great advice, instructions, depending on what hardware you might be working with. We don't have any hardware. We are just simulating everything on our PCs. But what we're going to do is we're going to go down here to scenes, and FactoryIO has some pre-built scenes, pre-built factories for us, so that we can just jump in with a predetermined task and then try and program that with our PLC. So let's jump into the first one from A to B. This one it's extremely simple. We have one load, which is our conveyor belt. So we're going to drive our conveyor belt with our inputs. Our inputs being just the sensor. So we can do that. We can just use the sensor to drive the conveyor belt. But what I think makes a little bit more sense for practical application is if we add in maybe a switch or two. So we're going to go down here to operators, and let's say we want a start button. Let's put it on our conveyor belt. Spin that guy around, and that's on the conveyor belt. Okay, so we got a start button, and let's put an e-stop. Every good machine needs an e-stop. Safety first, folks. Let me see if I can grab this thing. I'm gonna spin it around. And boom, we have ourselves a start button and an e-stop and a sensor. So the goal of our program here is going to be to bring this box from the left-hand side all the way until it trips this sensor, in which case the conveyor belt is going to stop. Um, we have some controls here. We have the play button, so we can start our physics simulation, which is going to enable gravity. You can see the box drop down there. And it's also going to enable communication to this machine once we have our PLC set up. We'll just stop that for now. But this is what we're going to be working with. Just make sure you add in your start button, your e-stop. Everything else is already added in. So just make sure you're following along that far, and we will move on to CodeSys. Opening up CodeSys here. Just takes a moment to initialize everything. But when it loads up, you're going to have a screen something like this. Something like this. Perfect timing. Okay, so we can open up new projects. This is standard start page, recent projects. I already have CodeSys. I've been using it for a bunch of other projects. So you can see I have some files populated, some projects there. We're just going to start up a new project and a new standard project. We will call this one scene one. LD for ladder diagram. Scene 1 LD. Okay, so we've started our first standard project. The first thing it's going to ask is what device we want to use. There's a whole bunch of devices here. You can just leave the device as is. It's selected a controller that is installed on your computer. And we're going to do ladder logic diagram. But be careful, that is not the same as ladder diagram. Ladder diagram actually has fewer functions, fewer blocks than ladder logic diagram. If you want the full functionality, make sure you click on ladder logic diagram here. Okay, and it's just going to populate this project with everything we need. The standard project has our device and our program and library and all that stuff. It pre-populates that, which is why the standard project is better than the empty project to start. Well, let's take a look at what we have here. We have a device, which we're going to get to in a little bit. This is part of setting up our OPC server. A bunch of stuff there that we'll get into. PLC logic. We have our application. This is what we're going to be writing. This is our main program, PLC PRG. We're going to rename this real quick. That's going to be FIO. Stands for FactoryIO, just so we know what we're running this for. And it will automatically update that for all the references. So let's begin our program with adding in a couple variables. There are a few ways to do this. We can click up here, and we can click this little button to insert a variable. Let's choose one that we want to add now. At the start button. Start button. We do not need to assign an address because we're communicating via the OPC server, and it automatically exports our variables. We don't need to assign an address location. That would be for like Modbus if you needed to assign your memory locations. But this is Boolean, true or false. That's all it can be. That's just a simple button. And that is one way to add the variable with this little button right here. You can also just type in a name. Let's call this eStop. That'll be our eStop. Boolean again. Everything we're going to be working with in this example is Boolean. Another way that you can add variables is just if you have a connection here, I just click the contact button up here. Go in here and we'll just type in reflective sensor, because this reflective sensor string doesn't exist yet in our variables. It's just going to ask us to create a variable. So yep, Boolean again. And we can do that one more time. We're going to add a coil. This is what our load is, what we're trying to drive with our inputs. So we're trying to drive our conveyor. Conveyor Boolean again, on or off. We're not going to deal with voltages. We're not going to deal with analog signals yet. But you could have this set up from 0 to 10 volts or from -5 volts to 5 volts, which would give you a forward and reverse function. But we're not going to be dealing with any integer values or anything yet. Just strictly Boolean. All right, so we actually have our first little piece of logic here. We have a reflective sensor. We have a conveyor. The reflective sensor is a normally closed contact in our logic because the light uh, comes out from the laser or from the sensor, bounces off the reflector, and then returns to the emitter. So when it reads that it's got that beam returning to it, it's in an on state, and the behavior we're looking for is it turning off when something gets in the way. Let's start over real quick. I didn't really. I'm not referencing any other pre done ladder logic right now. I'm just doing this off the top of my head just to get us started. But let's make this a start button here. Start button. Perfect. Okay. Start button. We press the start button. Turns on the conveyor. All makes sense. Another thing we want to happen though is that when we press the emergency stop button, we want it to turn off. So let's add a contact here. E-stop. We got our e-stop there. E-stop is normally closed, so by leaving it in this configuration, that means that when the e-stop is not depressed, it will constantly be providing power. You got to kind of flip the logic in your head from normally open to normally closed. So we press the stop button, or we press the start button rather, and that will allow power to move from this leg to, or this branch to that branch. E-stop is always going to be closed until we press it and break the connection, so that will allow power through to the conveyor. So we can actually run this. This is a complete program. I mean, heck, even the start button was technically a complete program. So what we need to do now, because we want to pass these variables onto FactoryIO, is we need to make a symbol configuration. Where's symbol configuration? Right here. Support OPC UA features. And now we are going to build our variable list. FIO is the program that we've just made, so we're going to expand FIO and we can see what variables it's going to pass over. So we have conveyor, e-stop, sensor, and start button. We'll select all of those. That is good. Okay, so double check we have those. Now we have this program here, but how are we going to get it to connect to FactoryIO? We need to set up our device here. Our device is going to be what communicates with FactoryIO. So we're going to need to scan our network and get our device. You can see my desktop is currently set as the path. That is going to remain the case, but we need to turn on the device. There are 2 pieces of software running right now for CODESYS, technically 3, but we're going to ignore the gateway side. The other piece of software is in your tool tray here. So we see this little cube. This is our gateway. And this little cube here, the 64, that might say 32 if you're on the 32-bit. If you right-click that, we can click Start PLC, and now our device is active. It's active on our network. There we go, it lit up. So we can come over here and click Scan Network, and we're going to find the actual address of our device. Saying there's some sort of discrepancy. We'll just let it auto-update like we did before. And there we go. We have a device. This is the tricky part. Here I spent a good deal of time trying to figure this out. If you go to CODESYS, if I can go to CODESYS, or rather FactoryIO, if you go into the FactoryIO documentation for setting up with CODESYS, it only has up to SP17, and as of today, making this video, SP18 is what you'll be downloading. And there, if you're following this as your guide, it's going to change right around here. Change communication policy. Because we are not setting up an encrypted network, we don't want to deal with having to set up, a bunch of users and permissions and all that sort of thing. we would want to go ahead and change the communication policy to allow um, anonymous users. That is not in our current version of CODESYS. That if we go here, device, it should be around here. Communication settings. It's not this. That just, you can see it encrypts that line. What it actually is in here, security settings. So go into security settings. At some point, you might have been prompted to create a username and password. I already have mine set up. It's not necessary. You can have no password, but I set one up. We get into our security settings here. So remember that was under device. Down at the bottom, it was security settings. And now we want to open up CMP User Manager. And I might already have it set up myself, but let's see, where are we? This one here, user management, allow anonymous. Yours is probably going to say no right now. So this is probably what you're going to see. You want to switch that over to yes, and now we can communicate from our device to FactoryIO. That gives us permission to be an anonymous user. We don't need to sign in with credentials for that. I believe this is everything now. So we can go ahead and log into our device. And this is going to kind of bring our program to life now. It's going to be looking for, I come over here and see that. Yeah. So we logged on. We see that we have some quote unquote power here by that blue line. We're going to need to click play as well on our program so that it can actually run. And we can change our variables in here. So if I click the start button here, I went over to the prepared value sections and just clicked that once, and it says true. The keyboard shortcut for updating that value now to our PLC is Control F7, and you see that the power has moved one section of this branch further. eStop. It's not working yet, but it will work when we have it hooked up to FactoryIO. Just have to wait and see. But you can see now we've got power going from this left rail through the start button, through the eStop, over to the conveyor. So we are running the conveyor allegedly. We simulated. If we were to stop any one of these, it breaks the connection. Now the conveyor is no longer running. So let's jump into FactoryIO and have a look. There's still a little bit more setting up to do, but we're almost done. So we go into FactoryIO, and we're going to go to File, Drivers. And we are going to click up here, this drop-down menu, and go all the way down to OPC Client. So we're setting up FactoryIO as the client. We set up CODESYS as our server already, so this completes the network. Click on Configuration here. OPC Server. Mine's already showing up, but you might need to click Browse Servers. And we have our desktop here, OPC UA Server Desktop. You might not have these. I have LabVIEW and Rockwell Arena set up on my computer as well, so they also have OPC servers in their software. But we select this, and we are going to do something. So once we click Browse here, it's going to browse that symbol configuration for the variables that we put in. It's also going to pull up a lot of like global variables and stuff that is kind of hidden to us, but that CODESYS operates on. So we can filter all the extra stuff out by typing in FIO. Remember, we typed in FIO here. That's our name. So all of our variables are going to be have FIO in their name because that's part of their location. Type in FIO and we can hit browse. Oh, none start with FIO. So let's change that. Let's go to contains FIO. There we go. And it didn't shut us down there. And look at that. Okay, so this pulled our variables from CODESYS. We have the conveyor, we have the e-stop, reflective sensor, and the start button. And we can see those are our variables here. This is a really nice interface actually. I really enjoy it. All we need to do is just drag, like just plug and play with our variables to the buttons. These are the sensors, the switches that we have in FactoryIO. That's what the names are. It's good practice to try and name them similarly in your variables. Well, let's just plug everything in. Emergency stop, that's in. Start button, that's in. Sensor, that's in. And then over here on our actuators, these are our loads. These are our contacts. These are our loads. We have the conveyor, and we'll plug that in. And you may need to click the connect button up here. Mine's automatically connected, but that's it. So let's go have a look. Click the start button, and look at that. Click the button, and it moves. Now, if I press the e-stop button, it doesn't move because we've broken that connection. Let me pull this up side by side here. So we have FactoryIO on one screen, and we have CODESYS on the other. We can see our ladder here. When I click this, you can see that variable updating. We have communication between our two pieces of software. Let's hit that e-stop. So the e-stop's in the out position right now. We can actually kind of see this if we scroll in. Just how it works in the real world. E-stop is out, and we can run the conveyor belt. That's great and all, but I would really like it if we could just press the button and it would travel until that sensor's tripped. I feel like that's more in the spirit of what this scene is trying to accomplish. So we're gonna go back to CODESYS and we'll just log out. We logged out of there, and now we need to think about how are we going to make sure that the conveyor belt keeps running without having to keep the button to press. We want to press the start button and just let it do its thing. That's the point of automation. What we're going to do here, well, we have this this AND gate. This is the little AND gate here. We have if the start button is pressed and the e-stop is not pressed, then the conveyor runs. So we want to add one more condition to that. We want to add the retroreflective sensor. That also has to be active. So we can just drag this variable down to here and it'll add a connection. So this is our 3-condition AND gate. But we want to have another way to drive this conveyor belt. So all of our conditions for stopping the machine are here, but we want to have this machine run without us having to hold down the button. And the way we're going to do that is we're going to make a connection below. I don't think that's quite right. I don't think that's quite right. Can we do it here? Yes, we can. But we actually want it. Some of the branches are a little hard to navigate. So if you have trouble with it, just try some stuff out. It seems kind of random to me sometimes. There we go. We want to have 2 conditions for turning on the conveyor belt. But we want to have the e-stop and the reflective sensor both be the inputs we require to stop it. So we have the conveyor belt here as our load. We're just going to take this conveyor belt variable, and we're going to make that an input as well. So let's take a second to look at this piece of logic and see what it does. If we press the start button and the e-stop is not pressed, and the reflective sensor is, it doesn't have anything in front of it, then the conveyor belt runs. And if the conveyor belt runs, then this contact is also going to be true. So we can take our finger off the start button, and because this branch is also true, it is going to power the conveyor. Let's compile this and have a look at our program in FactoryIO. Just click login with online changes. It'll download your new ladder logic. Okay, so we have our two inputs, our two methods of turning on the conveyor, and we have our two stop conditions. So let's jump over to FactoryIO, see if this all lines up. We'll hit the start button. Okay, so currently, stop button is out. Sensor is not tripped. It's receiving signal back from this reflector plate. And we'll hit the start button. And just like that, keeps running, keeps running, keeps running. We'll see if it trips at the sensor. And there it is. So we can reset this scene, and we'll test our e-stop button. That should also stop the conveyor belt from running. It's running, something happens. And it works. Now, because of the way we wrote our logic, when we pop this e-stop button back out, the conveyor belt will not keep running. It will not start up again. We have to give it a new start button input, and then it will run again. You wouldn't want to have it where once you pop the e-stop out, your machine instantly starts up again. That's not very safe. So make sure you're testing for little things like this. E-stop shuts everything down. There's no other ways to power it on. It doesn't auto start when you pull the e-stop. Just for real life application, you want to make these machines safe for the operators. But that is it. We have our first scene here. So we've got ourselves a connection between two programs. We got CODESYS running as our OPC server, and we have FactoryIO operating as the client. We have a piece of ladder logic that runs this conveyor belt system, and we have a physical model to look at in FactoryIO. I think that is super cool. 30-day free trial on FactoryIO. I think I've had it for a couple weeks now. It's actually been a lot of fun to go through and play with a lot of the scenes, and we'll get into some more complicated stuff maybe in the next videos. But this is it. This is scene 1. Give that a save. Scene 1. Scene 1. Complete. Well, thank you very much for watching, and have yourself a great day. If you notice any inaccuracies, please feel free to leave them in the comments below, and I'll be back with another video very soon. Thank you.